Welcome back to my YouTube channel. Today we will discuss an TIFR exam question. Okay. Question is given that f is a function from closed interval 0, 1 to r and satisfy the condition integration 0 to 1 f of x 1 minus f of x dx equal to 1 by 4. Okay. Find the cardinality of that set of function satisfy this property. Okay. So now solution. Given that f is a function on closed interval 0, 1 to r, okay, and also given that integration 0 to 1 f of x 1 minus f of x dx equal to 1 by 4. Okay, so this implies integration 0 to 1 f of x minus f of x whole square minus 1 by 4 dx equal to 0. Okay, so this implies integration 0 to 1 multiplying by minus 1, we have f of x whole square, okay, into minus 2 into 1 by 2 f of x, okay, and this is 1 by 2 whole square, okay, dx equal to 0. Okay, so this implies integration 0 to 1 f of x minus 1 by 2 whole square dx equal to 0. Okay, this is my equation number 1. Okay, and we know the result. We know if hx is a function on closed interval 0, 1 to r is continuous plus hx getting equal to 0 and integration 0 to 1 hx dx equal to 0, then this implies hx equal to 0. Okay, so applying this result, we have here already given h is a continuous, here already given f is a continuous. Okay, so f minus 1 by 2 is also continuous. So we have, using this result, we have from 1 f of x minus 1 by 2 is equal to 0, because this is getting equal to 0 and this is also continuous function. Okay, so this implies this, using this result, we have f of x minus 1 by 2 is equal to 0 whole square, okay, equal to 0. So this implies f of x minus 1 by 2 is equal to 0. So this implies f of x equal to 1 by 2. Only one function, that is f of x equal to 1 by 2, constant function. Okay, so set of this cardinality is 1. So answer is B.